The most basic tools we use when we count are addition and subtraction. So let's look and see how we use those. Let's start with addition. So the addition principle says that if there are m ways to complete task 1 and n ways to complete task 2, then there are m plus n ways to complete task 1 or task 2. So for example, let's ask in how many ways can we choose a letter A through Z or a number 0 through 9? And the answer is, well, there's 26 ways to choose a letter and 10 ways to choose a number. So there are 36 ways to choose a letter or a number. And then we could ask the probability question. If one of these letters and if one of these symbols is chosen at random, what is the probability that it is, let's say, capital J? And the answer is 1 over 36. Assuming we don't have any feeling or opinion about which one of the characters is going to get chosen. You can think about writing them all on pieces of paper, putting them in a hat, and mixing them around. If all the pieces of paper are the same size, then we would have equal confidence that any one of those pieces of paper would be chosen. There are 36 symbols, so 1 over 36 is the probability that any one of them is chosen. All right, let's look at another example. Let's ask how many numbers x satisfy x's between 1 and 30 and x is odd, or x is between 31 and 40 and x is even. So we can count the number of numbers x in each of these ranges satisfying the properties pretty easily. And then we just add those numbers together to get the total number of numbers that satisfy one of these properties. Either x is between 1 and 30 and is odd, or x is between 31 and 40 and is even. So from 1 to 30, well, there's 30 numbers, half of them are odd. So the answer is there's 15 of those. And then here we basically have 1 to 10, and there's 5 of those that are even. So 15 plus 5 equals 20. And then we have the related probability question, of course. If one of these is chosen at random, then what is the probability that x equals, say, 38? And the answer is that there's 20 of those numbers, so 1 over 20. All right, now the subtraction rule is not too much more difficult. The subtraction principle says that the number of ways to complete a task while following a rule is equal to the total number of ways to complete the task minus the number of ways to complete the task while breaking the rule. So for example, let's consider the question, how many numbers between 1 and 100 are not multiples of 6? Now we could answer this question by thinking about the numbers one at a time. One, two, three, four, five, skip 6, 7, 8, 9, etc. That would be sort of a long and tedious way to answer the question. It's better to just say 100 minus the ones that are multiples of 6. So 100 minus the bad ones, multiples of 6. And that is, let's see, how many multiples of 6? We could go from 1 to 60 first. And then there's 10 multiples of 6 in there. So maybe I'll write 6 to 60. 6 is 1 times 6, and 60 is 10 times 6. So there's 10 right there. And then we could go from 66 to 90. That should be easy too. So, sorry, 66 to 90. That's 11 sixes, and that's 15 sixes. So 11, 12, 13, 14, 15, that's 5 more. And then 96 is the next one, and then 102 is too big because we're only looking at numbers between 1 and 100. So 96 is 16 times 6, so plus 1. So there's 16 multiples of 6 in there. So 100 minus 16, our answer is 100 minus 16, which is 84. 84 numbers between 1 and 100 are not multiples of 6. And then if one of these is chosen at random, say X is the one chosen at random, then what is the probability that X equals 71? And the answer is we decided there's 84 of them. If they're chosen at random and we don't have any stronger opinion about which one is going to be chosen and given to us, then the answer is 1 over 84. So another related question we could ask is, how many even numbers from 1 to 100 do not begin with 5 or 6? Again, we could think of all the even numbers one at a time. 2, 4, 6, we'd throw out 8, 10, 12, etc. Go all the way up to 100, but that would be a drag. It'd be better to, I'm sorry, this is 100. Do not begin with 5 or 6. So we know that there's 50 even numbers from 1 to 100. So 50 minus the bad ones. Which is 50 minus, so from 1 to 10 there's 6. And then from 51 to, from 50 to 59, there's 50 up to 58, and then 60 up to 68. So those are the two-digit even numbers that start with 5 or start with 6. So we've got 5, 5, and 1. So it's 50 minus 11, which is 39. And if one of these even numbers that doesn't start with 5 or 6 is chosen at random, so if X is one of these chosen at random, then what is the probability that X equals 18? Well, we're choosing one of these at random. There's 39 of them. The answer is 1 over 39. Same as if we chose 16 or 24 or 32. Any one of these chosen at random. Chosen at random means that we don't have any opinion that one of them is more likely to be chosen than the other. Again, maybe they're all written on pieces of paper that are the same size and same shape and put into a bag and mixed up. So there's 39 of them, and the probability that any given one is going to be chosen is 1 over 39. The end.